Okay, so let's get into these questions now that we've tried a few simpler questions. So 7.4, substitution to solve linear systems, and this is outcome R9. Okay, all right, so here we've got these two equations. Now, what is our goal when we have two equations and they have an x and a y in them? What are we looking for? We need to solve the system. What does that mean? Find the xy point where they intersect, right? Okay. Now, notice we have 5x minus 3y equals 18, and then we've got 4x minus 6y equals 18. We want to try to isolate one equation with only one variable. Now, we've got two variables here in both of them. And what I want you to do is I want you to notice how I can rewrite this second equation so that I've got 4x minus, and then I'm going to break up the 6y. I'm going to break up the 6y so that it looks like 2 times and then 3y. Do you agree with me that when I multiply this 2 and 3 together, I get back to 6y? Yeah? Okay, good. So that's the key to solving this equation more easily. Now, how do you think I can rearrange the first equation so that I can replace it within this second equation? What do you notice that is similar here? The 3y and the 3y. So what if I solve this for 3y? So I have 3y equals and then a bunch of stuff on the other side. Okay? That's our first task. So let's do that. And I'm going to start working over here. So 5x minus 3y equals 18. And I'm going to arrange it so that I have it saying 3y equals. Okay, so how am I going to do that? I can add 3y on both sides, and then I can minus 18. So then I'll have, let's see, 5x minus 18 equals 3y. So I've got my 3y, and it equals this. So do you remember this equation right here? So what I'm going to do is I'm going to replace this in for the 3y. So instead of 4x minus 2 and then 3y equals 18, I'm going to write 5x minus 18 right in here. And what is that equal to? That's equal to 18. All right, so now what do you notice we have here? We have an equation, and how many variables are in this equation? Just one. So we can do what at this point? I can distribute this -2 through and combine like terms. So this is going to give me -10x, and what is -2 times -18? Positive 36, and that's equal to 18. Okay, so now over here, we notice we have, what are these guys called? Like terms, yep. So that's -6x. And do you guys mind if I just move this 36, subtract 36 on both sides right now, up here, and then just write what it equals down here? So what do I get over here? -18. Okay, so is this working out nicely? Divide both sides by -6, and what do we get as x equals? So we get x equals +3. Okay, Let's keep that in our pocket because we need it for the next part, right? So what's the next part here now? Take the x and we can plug it back into. Now, does it make a difference which one we plug it back into? No, either one will work, so it's player's choice here. You can decide and plug it in. And what are we going to hope to get out? The y value, yeah. Okay, so let's use the first equation here then. 5x minus 3y equals 18. And then in for the x. That tail on that 5 was too long. 3y equals 18. And then we've got 15 minus 3y equals 18. Now, how do we want to deal with this? Minus 15 on both sides. Negative 3y equals 3, and then y is equal to negative 1. Okay, so that's one more piece of the puzzle. So what's our final answer to this system then? So the solution to the system is, and how do we state our answer? What does it look like? It looks like a point, yeah. So coordinate point, 3, comma, negative 1. Cool? Yeah? Okay. Now, I want you guys to take a second, and the next question says, create a linear system for this model. I'm going to zoom out 1 second. And I want you to just kind of take a chance and try this and see if it works for you. See if you can come up with a solution for it. Okay, so now that you've had some think time to think about it, let's get into this question a little more. So it says Alexia invested $1,800, part at an annual interest rate of 3.5% and the rest at an annual interest rate of 4.5%. So how many investments does she have? She has 2 different investments. What should we call the 2 different investments? Let's call the first investment X, and what should we say that investment is? So it's X, maybe dollars, at 3.5%. Now, we're going to use 0.035x instead of 3.5%, okay? So, because percent means for every 100, right? And now, what about our second interest, or second investment that we're putting in? What should we say that is? That is y dollars at 4.5%. Now we're going to use 0.045 times y. So if I had $100, I would multiply it by 0.035, and that would tell me how much interest I've made on that investment. For investment Y, if I had, for instance, $200, and I multiply that by 0.045, that's going to give me how much interest I've made off of that amount of money. So altogether, combined, how much interest did she make? The total interest made is how much? $73. It says after 1 year, the total interest is $73. And then how much did she invest in total? Yeah, her total investment was $1,800. So let's look at the easy part first. How do we come up with the total 1,800 as an equation? Well, how much did she invest? She invested X dollars in one investment, Y dollars in the other. So if we add those two amounts together, we should get 1,800. And then for our second part of our second equation, that gives us how much our interest is. Well, this was for our first part, and our second part, we add that together and we get the total interest. So 0.035x plus 0.045y, and that equals $73. So this equation is for the total dollars, and then this equation is for the total interest, right? Okay, and now the second part says solve this problem. How much money did Alexa invest or in each investment? Okay, so we have these two equations. Now let's solve the first one. Let's solve the first one for x. So let's say x equals 1,800 minus y. Now where can I replace an x for an 1,800 minus y? In that x there? Okay, so let's do that. 0.035, and then instead of the x, I'm going to write 1,800 minus y. And this is where, this kind of question, you're going to have access to a calculator because we've got all these decimals going on. Okay? So 1,800 times 0.035 is 63, and then minus 0.035y. I need to finish writing the rest of the equation down, hey? 0.045y equals 73. So then plus 0.045y equals 73. Okay, so now I'm going to add these two numbers together, and what do I end up getting for that? So I get 63 minus, and then 0.01y equals 73. So let's subtract 63 on both sides, and that gives me minus 0.01y equals 10. So divide both sides by negative 0.01, and what do we get for y? So 10 divided by 0.01, y equals 1,000. Okay. I feel like I have an extra negative. This shouldn't be negative. This should be positive, right? This whole time? Okay. Did you see that? So this should be positive right here. That all should be positive, and then I should get a positive $1,000. So in investment Y, she put $1,000. How much did she put in investment X? 800, right. And you could almost do that in your head, right? Because X plus Y equals 1,800. If X plus 1,000 equals 1,800, so X is equal to 800. So our solution to this system is, in investment X, she put in 800, and in investment Y, she put in $1,000. So if we're graphing it and showing as a point, this is how we're going to write it. And so we could say she had $800 at, what's the interest rate that was associated with the X? Let's go back up here, at 3.5%. And then $1,000, put a 1 there, at 4.5%. So this would be, you would have like a sentence that involves this information in it as your final solution. Sound good? Okay. Now I'm gonna let you guys have a couple of minutes with this question. Try to do it, because we did one earlier just like it, right? So let's try this again, and we'll come back and we'll discuss the answer. Okay, so since these, the fractions in this equation here, in this system here, they are different, right? So what can we multiply all together everything by so that we eliminate all of the fractions here? By 10. And then what does that equation become? So if we multiply this by 10, this by 10, and this by 10, so what do we end up with? 10 over 2, I can reduce that so that it's 5x. And then how about here? I've got 10 over 5. What can that reduce to? 2. So then if I have a 2 here, it's 2 times 4, which is 8y. And then what about this 10 and this negative 2? There's nothing to reduce, is there? So it's minus 20. All right, so now here, this one, what can I multiply both of these, what can I multiply across this entire equation so that I eliminate all of the fractions? So 8 is my lowest common denominator, right? So I've got 4 times 2 is 8, 8 times 1 is 8. So let's multiply everything by 8. And we want to multiply every term. So what's going to happen with this first one here? 8y, okay, and then what's going to happen here? I can reduce out a 4, so I end up with 2x, so equals 2x. And then over here I've got an 8 over 8, so minus 3. So I'm left with a 1. 1 times 3 is 3. Now this looks like a very normal system that we've started off with, right? Yeah. So now all you have to do is do substitution, eliminate substitution on this, and that's it. So the answer to this, I'll just tell you guys the answer, is x equals negative 23 over 3, and y equals negative 55 over 24. So try that on your own, and we'll have a look at it tomorrow, okay?